We will continue on with functional testing. This is chapter 10. So last time we talked about the adequacy criteria, which is really just a way to come up with how we can determine if our test cases are giving us what we want, basically trying to give us the right confidence that our software is working correctly. And one of the ways we talked about doing that is with something called functional testing. Functional testing should be your first, well, one of the major, maybe not necessarily your first, but one of the major types of testing that you'll do. And it's really just black box testing. You have the software and you're going to go hammer on the keyboard or figure out some test cases to try and break into it. And this is very popular with different pieces of software. Maybe you have a banking software where people have to log in. You'll probably come up with a lot of username and passwords, and then maybe from there, how can they go about manipulating the software? Maybe they can figure out how to either break the banking software or not do the correct type of deposits or withdrawals, or break into other people's accounts. So functional testing is very important and done a lot. All right, good old Jackson. So functional testing, also known as specification testing. I just called it black box. The point is you don't look at the code. You don't see the code, you just have the software running, and you're going to try and describe what the behavior of the program should be, either formally or informally, but hopefully formally, because those actually lead to direct test cases. First off, when we start doing functional testing, you have to think about, do you want to do any type of random testing, or do you want to do systematic testing? So random testing is, let's say for example, with the login to a bank, you might just randomly put in username and passwords to try and figure out if someone can log in from that screen. What's nice is it treats all input equally and there's no designer bias. On the other hand, systematic will be, okay, something that's valuable, maybe an actual legitimate username and password versus not, and maybe some, try and do some SQL injections or other type of breaking into the code as well might be another good systematic. So systematic, you're actually sitting down and trying to think about what would be a good test case, a positive one, some negative ones, and then of course maybe some malicious hacker ones as well. When it comes down to the point of this is functional testing and systematic. You want to sit down and actually think of good test cases, and we'll explain why in a moment. And actually get you a really good example. Let's just think of a root problem where you're trying to figure out the roots of a quadratic formula as given right here. Now let's say the program does not properly handle the case where b squared minus 4ac is equal to 0 and a of course is 0 as well. Well, it's going to be very hard for a random sampling to choose 0 and 0. It's very uncommon that would likely, pretty remote. Well, anyone doing a system or any type of test cases, that'd be the first thing I would do is say, let's try a equals to 0, and then let's try taking the square root of 0 as well, et cetera, et cetera. And try and get those corner cases because that's what we're used to seeing and that's what we're aware of. So this is an example of why you want to do your own type of testing and not having just some random analyzer do all the testing for you, although the random inputs can be useful in certain situations. So the author is really trying to hit home on this, that you don't want to do random sampling. Another example is think of all your programs. Hopefully if you've tested a lot, there's not too many errors. Maybe there's just a couple of needles in that haystack. Well, if there's just a couple of needles, it can be really hard for a random sampling to find it. The point of this slide is to tell you that a lot of times these errors are very well grouped together. If you're trying to, maybe there's a certain group of SQL injections that work very well, while other type of command line injections don't work at all. Good logins work fine. Strange logins that should fail, those work as well. Those error out as well. But maybe you do have a couple other buffer overflow situations. So the point here is that with your systematic testing, a lot of times the errors are grouped together. And so when you sit down and you do some functional testing, think about it that certain errors may lead to more errors as well. And that's why this leads to what's called the partition principle. So beforehand we mentioned that a lot of the errors come together. So with the partition principle here, you want to partition out the errors into different, they call it quasi-partitioning, different groups. So back here you might have SQL injection, and then maybe here's some buffer overflow. over here you might have a lot of positive logins. Maybe over here you have some failed logins as well. Notice that the SQL injection buffer overload should be over here on the negative logins, because those should just flat out fail, while they're not over here on the positive logins, because of course those are supposed to log in correctly. The idea is just to partition them out into different groups of test cases, and don't be afraid if the classes overlap. That's okay. No one really complained about having too many test cases, unless of course your test week took weeks to complete. But there's usually other reasons for that. Let's see, another good characteristic of functional testing is working with the specification. For example, with the roots program, we already knew to check 0, 1, and 2 as real roots. We didn't need to actually have the code in order to do that. We can just look at the test, or look at the specification, start writing test cases. We can use our experience to help write the tests that are actually needed, and hopefully as a master student you at least had some experience writing these test cases. If not, just keep in mind that, hey look, as you write more and more of these, you'll start to get the hang of what type of test cases you need to be writing. So why do we do functional testing? So we talked a couple things about what it is and the characteristics. Why do we use functional testing, or why is functional testing used so much? Well, there's a lot of characteristics of functional testing that pretty much everyone likes. First off, it's timely. You can actually start writing these test cases before the code or even after the code. It doesn't, for getting them written, it doesn't matter, although it's usually a very good idea to at least write some of them before you code, so you have an idea of what your code should be working against. They're usually pretty effective. They'll find classes of faults, maybe missing logic. You forgot to scrub your input for SQL injections. Widely applicable. They're for many different programs. So I've talked about a banking software. You can do it for simple mathematical calculations. You can also do it for medical equipment, for simple applications or Android apps or mobile apps as well. Economical. Usually they're less expensive than any type of structural, because instead of having to do a full code analysis, you just look at the specification and start writing inputs and outputs. So usually they're fairly straightforward and simple. The author harps on this a lot, and I do agree. Program code is not necessarily functional testing, so you should be writing these test cases as soon as possible, especially for large applications. Writing the test case early can also help you with ambiguities before you start coding, which is helpful during the design phase as opposed to the coding phase. It'll let you fix those errors earlier. Also assesses how testable your code is, and is exploration of the specification. XP here is for extreme programming, an older type of programming model, not used too much anymore, but I will say Agile is kind of an offshoot from extreme programming. So how does this compare with structural? I'm not going to say functional is 100% better than structural, but there's definitely characteristics of functional that are better. For example, you don't need the code. And usually when you use a combination of different type of testing, it's best for missing logic faults. So any type of logic you may have missed, it's usually pretty good at finding them. Structural is not very good at this, because if you never had the logic and specification, you probably didn't program it, so it's not part of the code, so you can't do a structural test, since the code was never there to begin with. But as a functional test, you can, because you knew it was something that you should be thinking about when you're writing your test cases. Also, functional can be very granular. You can do little units, you can do some API, maybe a full system test as well, and then you can also do something called regression. And this is very popular in large applications, so you'll have a regression test suite, namely once you commit the code, they'll kick off a full test where they'll run a full regression test, aka all the tests that people have stored up over time, and hopefully all those will pass and you haven't messed up something else. Well, on the other hand, structural really only focuses on unit and integration testing. Okay, so the book goes through the different steps. I'll go through these pretty briefly. These should be somewhat intuitive. You get your specification, kind of decompose it and break it into independent testable features. Select different, well, they say representative. Select different inputs to represent different things. For example, after the user is logged in, do blah, blah, blah. Maybe put these, after the user's logged in, select this icon up here. Did you get the proper view afterwards? Next come with actual test specifications. Combination of input values or model behaviors. Make sure these are inputs, those are outputs, write them down, and then produce and actually execute the tests afterwards. So specification, come up with some independently testable feature, either come up with the represented values or from the model, and then write the test case specification, and then actually write the test case. Here's a great example. So simple, USPS. It's an updated website, but they still have this feature where you can input a zip code, and they'll tell you some values that the cities that are in that zip code. So the question here is, well, what are some representative values here? So the zip code, so it's a 5-digit US postal code. What are some values you should put in? Well, as always, 0. Whenever I see a number, put in 0 first, then put in 1. Those are usually, whenever there's a number, that should be instinctively, those are the first two you should test. Then the next would be, of course, int max and int min. But anyways, next would be malformed zip codes. Maybe they didn't put anything, empty, 1 to 4 characters, 6 characters, or a whole bunch of characters. Maybe you can do buffer overflow. What happens if you put in an alpha number? What if you put a non-character data, something that's not alphanumeric? What happens when that goes in? And then, of course, what happens when they actually put in the proper zip code as well? So hopefully this will help you understand. You got to be at least somewhat maniacal in selecting your test cases, because you want to make sure that your code does not break the system that's running behind it. Okay, I talked about functional testing. We talked about quasi-partitioning, so you can figure out what you need to focus on, and that summarizes it for it. So that's it for this week. We're just doing chapter 9, which talked about the adequacy criteria, and then functional testing as well. I'll go ahead and put out the homework, which should be basically all the problems at the end of chapter 9, 10, which isn't too much. And if you have any questions, please email me. Make sure you finish up on your project proposals. Those are due on the 22nd, which is coming up fairly soon. Let's see, probably about 4 more days. So please come up. Please make sure you get on that. If you've been having any issues writing up the proposal, do email me and we'll take it from there. All right, guys, have a good week.